first up is Elena Reyes. Elena is Head of Building Certification in the Passive House Institute in Darmstadt in Germany, and obviously very experienced in relation to the design and certification of passive house buildings. She also has experience in teaching sustainable architecture at university level and has been involved in a significant amount of research and publications in around urban upgrading, life cycle assessment of construction materials and the passive house. Elena will then be followed by Shane Kinsella, who's Head of Sustainability of Mozart. So most of our Irish audience will be very familiar with Mozart as one of the primary companies in relation to passive house design and certification in Ireland. He comes from a building services engineer background, so very knowledgeable in relation to building physics and mechanical services. He leads a team in Mozart certifying passive house buildings in Ireland, the UK, and in North America. So we'll have our two speakers, and we followed. If you have any questions, it'd be great if you could pop them into the Q&A box, and we'll try and deal with those at the end of the session. So just before we kick off, I might invite Caroline Ash-Brady, our new Passive House Association of Ireland chairperson, just to give us a quick update in relation to things that are going on in the association, and then we will start the presentations.
That's great. Thank you very much, Helena, and welcome everybody to our event today. As Helena said, and I've mentioned, I'm the new chair of the Passive House Association of Ireland, and Barry McCarran is vice chair of the association. At present, there's been a change in the Irish landscape in terms of the number of builders and developers looking at passive, and a number of the very large construction companies in Ireland are currently on site or planning and designing to be on site for passive build. This is a very, very exciting move within the Irish construction industry, and something many of my colleagues on the board for many years have been advocating for in Ireland. Elena represents the Institute, the Passive House Institute today, and they've been working hard on the EasyPH to make the software more user-friendly and more efficient for designers and modelers. So we're really excited. Just to say that Shane will moving forward, we'll do more detailed webinars for us on the software. So we're planning 3 to 4 sessions after this, where you can come back and we'll take each part of the software and just get into more of the nuances and the nitty-gritty. So today, focusing on an introduction. So we welcome everyone today, and just to note that you have the Q&A box during the webinar. Pop your questions in there if you have any, and then Helena will administer and moderate through the Q&A at the end of the session. Thank you for everybody for logging on. Just one thing, I'm going to pop into the chat a link to our Passive House. If you're not currently a member of Passive House, we are but a strong advocate for Passive House. Just remember that there's an opportunity to join our association and help us to continue our work in this space and support industry and our colleagues working on Passive House all the time. So great, we will hand you over to Elena now, and she will get started on her presentation. Please, everyone, enjoy.
Perfect. Thank you so much, and thank you for the invitation. Let me just sort my screens out. I think I need the right to share my screen.
Brian, you might take care of that there for Elena.
Yeah, working on it now. Sorry, guys.
Great. Thank you so much.
Okay, well, we get this sorted out as Helena and Caroline already mentioned. Shane and I are going to talk to you about EasyPH. So I am going to start with the general concept of the tool, and then Shane will walk you through an example that he carried out so that you can get more familiar with the different features of the tool. I still cannot share my screen.
Okay, do you want to try there now?
Ah, perfect. So you should be able to see my presentation now.
Yep.
Great. So, 1 second. So the basis of everything that we do at PHI is the criteria that was set in the 1990s. And so the core definition has not changed. Whenever we talk about new approaches or new developments, we are actually thinking about two goals. The first one is to streamline certification, or in other words, make certification fast and easy. And the second one is to expand, to have more typologies designed and certified as Passive House. That includes, for example, in the later years, swimming pools, hospitals, and now we're talking about laboratories designed and certified as Passive House buildings. The topic of today is going back to the more common typology, which is single family homes, and it's called EasyPH, which is a tool based on PHPP. And the hope and the aim is to make certification, and not only certification, but the planning of single family homes easier. So the first part from my side, it's a few slides about the concept behind it and the general workflow that you need to use the tool. And the second part is the example that Shane will dive into so that you understand better, or you take a closer look at the file itself. So why focus on simplifying certification of single family homes? Well, as you probably already have experience with single family homes, we typically have smaller teams. So we also have smaller budgets. And at the same time, projects may be quite different one from another, right? So we have a lot of details that we have to check during certification, and this becomes challenging. So even if teams are interested in building certification, that adds up to the budget and may become an important part of it. So the easier and the faster we can make the planning and the review, the more affordable we can make this option. And let's not forget that in many places where we don't have passive houses yet, this is the first choice, right? The people think, oh, I want to try passive house, I will start with a single family home. So the easier we make it for everyone, then the better and the faster we can have a passive house all around the world. And then we have these projects which become exemplary projects and are the reference for other people to also do passive houses in these new regions or countries. So EasyPH is basically a modified version of PHPP, specifically the latest version of PHPP, which is 10.6. But we've managed to work on the assumptions that we need for single family homes so that we have simpler and way less inputs than we do in the normal PHPP. So to give you an idea, instead of the 40 something worksheets that we have in the normal PHPP, we only need 8 input worksheets. The scope of the tool is at this first stage only for new builds, and you can actually calculate up to 2 dwelling units, but only if they share the same ventilation unit. So this is what the tool is aimed at the moment, and we hope we can make some changes to, for example, also include retrofits, but we started with new buildings. So from these worksheets, we have, as we also do in PHPP, a worksheet called brief instructions. In this case, it's called brief instructions EasyPH, and that's just basically the best place that you can start with your calculation. It gives you an overview of the workflow, the different formats that we use in the worksheets, and then what information is expected from the project in each of the different worksheets. EasyPH is also an additional worksheet here, and that becomes the main input worksheet. So that's where you have all the information that you need for the project, and then that information is linked to the original PHPP worksheets, which are actually in the background, but they're hidden because they cannot be changed in this case. As you will see with Shane afterwards, EasyPH worksheet is structured in categories, and those categories are basically the ones we typically use for the planning and design of passive house projects. So based on the geometry, and then the ventilation systems, heating systems, and so on. So it should be, if you're familiar with PHPP, it should be relatively easy for you to use EasyPH. So how does it work? If you look closer at the EasyPH worksheet, we start on the left with sort of a format that works as a checklist. And this is intended so that the designer and the certifier have an easy overview of the status of the different categories and whether more information is needed or if that category is complete and correct for certification. The next section is the description of the tasks. So what is expected in this category, and it's meant as guidance on the information that you need to calculate the energy balance. And it's divided into two parts. One is the recommended approach. That is the approach that will make planning and certification easier. And there are other options also given there, but these options may need more time. If you use them, then you will need more time to carry out the model and for the certification review. Next to that, we have different links, either to the worksheets that are still present in EasyPH, for example, windows or components, or to very useful resources where you can get information that you need to calculate the energy balance. And the last section is the main one, is the one where you input all the information about your project. EasyPH is also thought out so that you can use it with DesignPH. So you can carry out your DesignPH model, enter all the information about your thermal envelope, and carry out also the calculation about the shading. And that is, in my opinion, the best approach, because that makes everything easier. And then if you use DesignPH, you have already completed 5 out of the 8 worksheets in EasyPH, and you're almost ready to go for certification. Just a small note, you have to export with the option geometry and components so that you don't overwrite any of the formulas that we have on the hidden worksheets. To give you an example of the simplifications that the tool has, I wanted to show you, for the example of the domestic hot water demand calculation. With PHPP, you actually need a very detailed calculation, and you need to enter all the information from the circulation and individual pipes with exact measurements of all the different trajectories. And you also have to enter detailed information about the storage tank. So this is possible, but I mean, it's quite time consuming. So with EasyPH, we have very reduced entries for the pipes, just a few measurements here and there, and then we make an estimation of the losses based on the selected type of distribution. So if you say it's a compact distribution scheme, then the assumptions are more positive, and then if you say that it's distributed throughout the whole house, then the assumptions are a bit more negative. I think Shane will show you also the example of the house that he had calculated for more clarity. But then instead of having to also submit all the different domestic hot water drawings with the measurements of each of the pipes and the diameters, then you just enter a few values, and then we have to have a general idea of how the system is distributed and not all the details. In terms of the guidance, I just wanted to show you also an example. This is what you can use for the window installation situations. So the recommended approach, again, this is what will make the whole calculation easier, is to actually start with inputting from DesignPH. And then for the actual values of the thermal ridges, you can either use similar installation situations for thermal ridge catalogs, or enter installation situations from the component certificates if you're using certified components. So what is implied here, but it's not per se an attribute of the tool, is that we start with good planning, right? The better our installation situations are, then the more examples we can find in catalogs because they will be similar. If we have very specific details only for our house, then it might be harder to find similar installation situations. And then we would have to use the second option, which is calculating our own thermal bridges. And that, of course, takes more time, both for the designer to get the values and for the certifier to review the project. And in terms of the example of the resources that we have, or the links that we include in this category, then we have the link to the components worksheet so that we can enter the values, but we also have the links to the component database where we can find examples of certified components, and to other catalogs that PHI has made available, which include different installation situations for concrete, building assemblies using concrete or building assemblies using wood. So we hope with at least with these examples, we can cover a large portion of the typical installation situations, and you don't have to calculate thermal bridges for your specific project. And then, of course, we still have the verification worksheet. The difference between the PHPP or the normal PHPP and EasyPH are these pink cells that you will see throughout the different worksheets. Those are the cells that are linked to the EasyPH worksheet, or that are fixed and cannot be changed, but same criteria, same verification method with specific values, and everything again in the verification worksheet. So hopefully we have piqued your interest and you're wondering, how do you get EasyPH? So EasyPH has been released together with PHPP 10.6. So the 10.6 was sent out to PHPP users in April this year. And we have released this as a first step as a beta version, but you can already use it for certification. So all you have to do is notify your certifier that you want to use EasyPH. And please, please, please send us your feedback and your comments so that we can continue to improve the tool. In case you want to share this information, there is a small, quick description of what EasyPH is on our website. So you find it under PHPP, and then there's EasyPH. And in case you're curious about other developments from PHI in terms of building certification, I also invite you to go to our site where we have the energy standards and criteria. And at the bottom, we have a section that is called Criteria Under Development, where we also describe a few new approaches that we are testing. And if you're interested, just contact us or contact an accredited building certifier for more information. And with that, I would let Shane show you how the tool works and how he filled it out for the project that he used as an example.
Thanks, Elena. No, that was a very good introduction. So I'll share my screen here now, and we'll get to work on the live project. Welcome everybody to the webinar, and I hope everybody finds it helpful. So now okay, can everybody see that there now? Well, good. Okay, so my name is Shane Kinsella. I am the head of sustainability at Mossart. So I lead the sustainability department, and I suppose I'm involved in passive house design, passive house certification. I'm a certifier myself, and I come from a building services background, and I've, I suppose, experience in everything from dwellings to commercial stuff and a little bit of high rise as well. So I suppose I come from a wide experience. So what I'm going to go through is I'm going to go through the project that we've used as a reference project here. So many of you may be familiar with this. This house actually owned by Barry McCarran, who I'm sure is among our attendees here today. So Barry built this house last year, and we certified it for him in December, and the house was certified as Passive House Classic. So the house had some it was originally an existing house, but actually when it was modeled, it was found it could meet Passive House, and it was certified as such. So you can see there on the right hand side of your screen that the heat and load of the house was 10 watts per meter squared. So that's that's the house we'll be using as our reference dwelling. So I suppose I've just set out just briefly here some of the key characteristics of the house. So the house achieved an N50 of 0.53 air changes per hour. We view values in the range of 0.1 to 0.13. We have all the vertical windows and external doors were all provided by Internorm. So they're all alu-clad windows with triple glazed units throughout, all that. So the design is quite good on that front. You can see there the U values are pretty decent. We also have some Velux roof windows in the rear of the house. So those are actually, I think they have 5 panes of glass in them. There's actually a triple glazed unit with an outer skin of glass, or an outer double glazed unit on top of that. So it's quite a hefty unit. That's a certified system from Velux. So that gives you a really good performance as well. So that's the key stuff. So on the ventilation side, there's a Renson MVHR system installed. There was flow rates were calculated both in accordance with TGD Part F, the regulation for Ireland, as well as Passive House, and it was actually found that the TGD Part F values were a little bit higher than Passive House. So that was the basis of the design. The MVHR system had an efficiency of 84%, and when we calculated it in PHPP, with including for the fresh air and exhaust ducts, it actually came back at 82.3% effective heat recovery. You can just barely see it in the first picture here that actually the exit point for the fresh air and exhaust is very, very short. And you can see the detail then where those ducts went out through the external wall of the house. So Barry had actually placed it very, very close to the external wall, so that run was minimized. Hence, the effective heat recovery was very high. We would sometimes see that value a lot lower. So the system, the electrical efficiency is given there, and it was 160 millimeter EPS duct system that had a 16 mil wall at 0.03 on the thermal conductivity. And then within the dwelling, then there was a radial system then to distribute supply and take back the extract back to the unit. So that's the ventilation approach. Then on the heating front, Barry installed an EcoAir air-to-water heat pump. So I provided some values here from the performance of that heat pump on the screen here. So you can see it has a pretty decent SCOP when it's doing space heating. That's at 35 degrees, as there is underfloor heating throughout the house. We can also see that domestic hot water efficiency is pretty decent there. We've a 2.31 on the SCOP for generating domestic hot water. So overall, the heat pump was a nice fit for the house. It delivers 3.3 kilowatts of space heating, which is more than enough for the house. The house had a load of approximately 2 kilowatts, so it was a nice size, and I think Barry has expressed that he's quite happy with the performance of it to date anyway. We also had a dual domestic hot water cylinder, then 500-litre cylinder. So that might seem quite a large cylinder for a dwelling, but I suppose bearing in mind, with a family and lots of hot water demand in the house, 500 litres often justified. So that's a dual 500-litre cylinder, and the heat loss was given from that provided by Joule, and that tank has an energy label rated as C. So those, I suppose, are the basic details that we used in our inputs into the EasyPH. So I'll move on to the EasyPH now. We'll take a quick look through it, and I bear in mind today time is limited, so I have to try and keep the presentation as short as possible. So we won't be going into massive detail here in it. But as Caroline said, there'll be further webinars on individual sections in it anyway. So we can see here that actually the house, when modelled in EasyPH, would actually comply with Passive House Classic. So we can see it's hitting the 10 watts per meter squared there, which is it was actually, when we go to decimal points, it's a little bit more conservative, using EasyPH in the order of about 0.3 watts per meter squared. so that there's a very small little penalty built in there, which I think is fair for the reduced paperwork burden. So the house would still be fully certifiable. So that's the, I suppose, the verification tab there. So as we start, as Elena said, there's 8 tabs fundamentally in EasyPH that we need to fill out. And I suppose within the brief description tab, there's plenty of information given there about what we must provide. So like we can see in the verification tab, there has to be obviously building description, summary results, etc. There's nothing really unusual there. Within the EasyPH tab, the vast majority of the design information, particularly on the MEP side, so to do with your ventilation, heating, domestic hot water, cooling, anything like that, nearly all goes in on the EasyPH page. Within then your other tabs, then so your U values is very same as traditional PHPP modeling. You put in your build-ups, etc., put in your correction factors, all that good stuff goes in there. Nothing unusual there, I think, for most PHPP practitioners. On the areas tab, then again, very similar to what you will see in a standard PHPP. Your areas will all come in, your thermal bridges, all that good stuff. The calculation of treated floor area is done in the EasyPH tab. So we'll take a quick look at that now in a moment. That's probably the big difference. A lot of people will calculate their TFAs in design pH, and as Elena said, your design pH must be based on geometry and components only. You don't pull anything else out from design pH. That's all you need. Your treated floor area must be calculated in EasyPH, and there's a good reason for that. So we'll take a quick look at that now in a moment. The building components database, again, should be familiar to most PHPP practitioners. You can put in your windows, you can put in your ventilation systems, your heat pumps, all that good stuff, all goes in as normal. There's really no major difference there, I think, for most people. Same with the windows and shading tabs. Again, the majority of that information will come from design pH if that's the road you're going on that. For most people, I think, again, we'll see very little difference here from traditional modeling. It would be the same kind of information coming in. You can put in your transoms, your mullions, assign your different framing sections, assign your different glazing sections, all that good stuff. All fairly standard. Finally, then you have the photovoltaic page. So there is a photovoltaic system on Barry's house. So we have included for that in the PV tab as well. So what we'll actually find is that is actually very easy to put the PV in. And again, for practitioners who are familiar with entering PV, they'll find no difference in practice. And I suppose on the right-hand side here, on this column here, it specifies what's required for certification. So basically, the first 7 tabs you must fill out for your certification, and then the PV tab if present. So if you're certifying to Passive House Classic and you don't have a PV system, there's no requirement there to fill out that PV tab. It doesn't apply. So therefore, we can completely ignore that if there's no PV system. So I'm just going to very quickly run through the main tabs before I go back to the EasyPH tabs, just to show you that there's really no difference here for most people. U values are all fairly standard. Fill out your areas, or fill out your section or your layers within your build-ups, put in your thermal conductivities, put in your thicknesses, etc. Same, go through all that process as normal. There's really no difference there. Same on the areas tab. It should be familiar to most people. The summary up the top will be pretty familiar to most practitioners. Again, you'll see nothing terribly different here. Probably the one thing you've got to is you have to cross-link your TFA across from your EasyPH tab. So that's just all you simply do is just put an equals in and then cross-link it to that output. Or you can type it in manually. I would tend to cross-link it, but a manual input is fine as well. The areas tab, again, all fairly standard, nothing really out of the ordinary there. Thermal bridge tab, where relevant, you fill that out. If you're not doing a thermal bridge free design, you'll put in your thermal bridges, all that. So nothing really unfamiliar there. Again, when we go to the components tab, it will all seem fairly familiar to most practitioners. You put your glazing types in, put your window frames types in, all that good stuff goes in. We can then put in our heat pump inputs if we're doing a detailed heat pump calculation. There is a simplified approach, which I'll show you, which will cover most projects. But where you want to get a more detailed result, you know, or maybe you're struggling a little maybe on the PER, you can look at the detailed approach. So that's there. It should again be relatively familiar to most people. Windows and shading is all fairly standard. You put in your window frame details. Most of it will come from ecph. Where you've transoms, mullions, etc. You can pull all that information in, assign all your installation thermal bridges, etc. Again, all fairly standard stuff. Same with shading. In this case, the shading was calculated manually for this case, but where you have a ecph model, you'll fill these two tabs will be automatically filled in along here for your reduction factors. So again, it should again all feel fairly native for most practitioners. And last but not least is our PV tab. Again, same as a standard PHPP. You put in all your information from your data sheets, etc. Put in how many modules you have, all that good stuff. Put in the efficiency of your inverter, etc. And then PHPP will do the rest then and calculate how much PV or how much electricity that the PV is generating, and then it will be able to work out then for I suppose any PER allowances, or if you're working towards plus, you can certify to plus in EasyPH. It's important to note you cannot certify to premium. If you're deciding to go passive house premium, it's not possible certainly at this time to certify a passive house premium dwelling using the EasyPH approach. You must go the full PHPP road. So just anyone advising clients around, and just be aware of that. For classic or plus, very easy. Premium, not happening. It's not currently on the table. So that's, I suppose, the key tabs that have to be filled out. I think most people will find that they're all fairly native for most practitioners. Again, your verification tab will seem fairly native for most people. Some people will be familiar with these. There's a set of tabs here on the right hand side that are typically filled out in a traditional PHPP. They're actually hidden away here. You don't need to fill those out. They're actually all done in the EasyPH page. So that's just a very brief overview of what we're looking at on as regards inputs. When we then get actually into the EasyPH page, we'll start up the top and we literally work down through the various sections. And as Elaine said, there's various sections here. So you have a section where the designer and the certifier can tick off work as it's completed and accepted by the certifier, and those little X's get filled out, etc. So that's a very simple approach. I think again, there's a recommended approach and an alternative approach here listed in the tasks. There's nothing, I think, too complicated in that. Most people can read it and just work through it. So we fill out our first tab is our project settings. So we fill out the key bits. We're going for passive house. We can certify a passive house or PHI low energy building at the moment. It's not currently used for EnerPHit. That's not on the agenda. And we can also certify them for classic or plus. We can't certify for premium. We can put the number of dwelling units in as 1 or 2. We can put the construction type here, which is used for calculating your thermal mass. So if you have a lightweight construction, you can select that. Mixed or solid. In this case, it's mixed because we have a mixture of timber and concrete. So it's a mixed construction. The year of construction can be entered. You can also enter your building location and your altitude, etc. Pick your weather file. It's important to note the weather file must be a PHI approved weather file. It must be in the main PHI directory. If you're using non-standard weather files, you can't use EasyPH. That's not permitted. There is also a secondary calculation over to the side when you put your location in that will allow you to pick alternative weather files and allow you to optimize which weather file might be suitable for your location. In this case, we've used Dublin. Dublin was the original weather file used for certifying the building. So we've stuck with Dublin for this example. But then we get into TFA and that kind of, actually, sorry, I missed the U value section here, sorry. So the U value section is calculated as normal in the U values tab, and that will pull that information in automatically. So we've nothing to fill out here. There's no inputs needed at this point. it's all done from your U-value tab. So then you get into the TFA tab. So the TFA tab is a requirement that this tab is filled out. We must enter the information here, and what this will do is it will calculate both the TFA, BN50, and it will do the ventilation calculations all in one sweep for you. So as we get into that section, we can see here that we can put the number of floors that we've in, so ground, first, second, whatever, however number of floors are in the house. And there is no TFA limit. There is no limit on the number of floors that can be certified using EasyPH. The criteria is based on number of dwellings and ventilation systems. You can only have one ventilation system. So you could conceivably have a 4-story, 5-story dwelling, perfectly fine, no issue. If it is a single ventilation system, it can be certified with EasyPH. So within this, we've itemized in all the room areas here. So we've put all the areas of the room, so to exclude internal walls, etc., all the standard PHPP measurement approach as per the manual. And we can assign the rooms then from the drop down list, and we can put in whatever the type of spaces that we're working with. Most areas will be living areas. You can put in for your stairs or elevators, etc. Any, say, circulation areas outside the dwelling or half landings or stuff like that can go in as well. Again, the tool will do everything else automatically for you once you itemize that in. We can then work out our VN50. We can put in our average room height. I've been a little bit creative here in the sense I've just taken 2.7 as a standard value. In reality, actually, the values are a little bit different in this house, but for the purposes of the example, I've just assumed all floor to ceiling heights are 2.7 for this example. Then we can go into the ventilation section and calculate our ventilation flow rates. So they will allow us here to put in the values in meters cubed per hour. You'll see here I've actually converted some of these from liters per second. The building was designed on liters per second, so I've just put some formulae in. That's perfectly fine to do that. So you multiply your liters per second by 3.6, will convert them to meters cubed per hour. We can then put in the commissioned information in this section here, so we can plug all those values in, and PHPP will then automatically calculate any discrepancies. Then normal rules apply. Plus or minus 10%. The fresh air and exhaust must not be outside of that range. We can put in our final measured values at our outside grills, can be plugged in there following the normal rules in the Pacific criteria. So ideally measured at the grill. If not, it can be calculated on board. And if that doesn't work, then you can add the various values together, but ideally measured at the outer grill is preferred. So all that good stuff is done. There's a little section down the bottom here for putting in some of your commissioning information. Your commissioning guys can sign off their bit within the Excel file, and that closes that bit of it out. And that will give you essentially all the inputs that are needed to do your EasyPH calculation. So I'm not going to dwell too much on the next few tabs because it's literally all been done previously. So your building elements, your areas, all that good stuff, thermal bridges, windows, all that information is picked up in the other tabs. Once you've all those filled out, you're good to go. You're ready to start putting in the ventilation systems and all that good stuff into the house. So we go down to the ventilation section, and we actually find it very, very simple to fill out. You literally have, two main tabs here that need filling out. So from the list here, we can select a certified ventilation system or a ventilation system that we filled out into our components tab. So anything in the components tab will be available here as well, which will be familiar to most practitioners. In this case, we had a Renson Endura 450 was what Barry put into the house. So that's within the thermal envelope. So we can select whether it's in the thermal envelope, whether it's outside the thermal envelope in a cellar or basement, or whether it's outside thermal envelope in like a shed or something like that, which ideally we shouldn't be doing, but sometimes there's no alternative. So you have 3 options there. You just select the relevant one. For our fresh air and outdoor ducts, we put in the length of the ducts, the diameter, insulation thickness, and then we can select an X there if they have a foil back coating on them or an aluminium coating on them, as we've seen from the photographs further back. There's no aluminium coating in this case. So therefore we leave that box unchecked and we input the thermal conductivity, which you get from your data sheet for your insulation. So that's basically your ventilation system entered. That there's nothing else to do now on bar just put those few pieces of information in, which I think is fair to say is very easy. So the second thing then we look at then is the kitchen hoods. I suppose we're aware most designers here that will try and put recirculation hoods in. I know in some cases there's regulatory requirements or client requirements or whatever that insist on ducted ventilation systems, and there is the possibility of entering those here. So we can select that from the drop down if it's an exhaust air hood or if there's none at all, which is unusual, but most cases recirculation. If there is an exhaust air hood, we can then begin to fill out these other sections here. Well, the efficient hood will apply for recirculation or exhaust air. And so we can, if it meets the criteria for an efficient hood in the exhaust air guidance document, you can tick that box. If not, you just leave it unchecked. If we have a ducted exhaust system, then we can put in whether the opening in the wall was sealed during the pressurization test. If it was, we apply an X in the box. If not, we leave it unchecked. And if there's an airtight exhaust flap, so basically if there's a damper, an airtight damper installed on it, we can check that box as well. So everywhere you'll see there's little notes, so everyone read the notes and that'll give you good guidance as to what you need to do. It should be straightforward, I think, on that front for most practitioners. The final thing we have to put in then is in our air change rate section here is we have to put in our final commissioned value. So the average of our fresh air and exhaust value gets entered into this box here. That will then calculate out the overall air change rate. And there's a little tool on the right hand side here that will confirm that all the criteria as set out in the pacifiers criteria are met. So it's based on supplier per person, overall air change rate, and then the discrepancy. So once in this case we can see here that we're well covered by the criteria. So all criteria fulfilled. So essentially nothing to see on that front for most projects. We can then begin to load in our air change rate for summer cooling. So there is the facility here to input various values. So we can put in, if we have a bypass system, which we should have for all passive house buildings, we can select that on, and then we can put in an increased flow rate if that's the case. If the ventilation system runs at a very high rate in summertime, that can be put in here to get the benefit of the cooling. There's some inputs down the bottom here then that we can look at for things like, you know, night ventilation, various other things, notes beside them all. Again, if the scenario applies, you tick them on. If the scenario doesn't apply, you tick no, or you select no in them and leave it at that. And then PHPP will do the rest from there. You don't need to provide any further evidence except maybe, you know, obviously floor plans, etc., etc. So that's that end of it. We will then put in our air change rate from our pressurization test. So whatever that comes back in air changes per hour. Vital that we check that the VN50 in the pressurization test is accurate. If that value is not accurate, then we will need to use an auxiliary calculation, which is provided here in the EasyPH tool. I actually noticed a little error in that, Elena. I might talk to you afterwards. It's actually calculating the wrong way around. So I've actually corrected it there. It's the two values were in the wrong order, but it's a very handy tool that we can allow us to convert from what the actual tested value was and then get an accurate input for our PHPP. So if we have cooling, we have a section here we can put cooling in. If there is mechanical cooling within the dwelling, we can select the X on here, and we can fill out a simplified or detailed efficiency. I'm not going to go into any detail today, and it's not really used all that much in Ireland, mechanical cooling. So, and even in the UK, it's rare as well. So I know many of our international projects would have mechanical cooling, but we'll go through that another day. I'm going to focus more on heating today, just to I know time is ticking away here, so I don't want to delay too much longer. We've two approaches here for entering our heating. There's a simplified and detailed approach. We assign our heat generator type. This will be familiar to anyone that's familiar with the PER sheet. We can fill that section out. And then we can go down and we can calculate what our efficiency of our heat pump is. So it's a simplified approach, which is very easy. We simply enter the nominal power of the heat pump, and we can enter either the seasonal performance of the heat pump or the SCOP. So we can get that information from various sources, from the manufacturer, from eco design data, all those various places we can get that data. If that data is based on 35 degrees, we must select the X in the box here. If it's based on 55 degrees, we don't select the X in it, and PHPP will do the rest. We can do a detailed calculation, which we'll do in another webinar, and that will tend to give more favorable values, but it requires more information. So for most projects, the simplified approach should get them over the line. If you're struggling with that, then you can go and take a look at the detailed approach. To be honest, it's not that much information needed for it, but in some cases you could be struggling to get that data. Again, when we go to domestic hot water, we have a simplified or a detailed approach, and we can put in our heat pump details here. We can put in whether it's an inverter heat pump, or variable speed as the case arises. We can put in our make, model, nominal power, same kind of information. We're able to input the performance of the heat pump there, and we shouldn't be using 35-degree data for domestic hot water generation. We should be using 55 as a minimum, or preferably, more detailed domestic hot water information like we see from, say, EN 16147 gives us some further, more accurate information. But if we don't have that, we can use the 55-degree data there to generate those values. So that's how you put your heat pumps in. All very simple, very little data required. Minimum amount of messing or tricking to be done with it. Very, very, very easy. This is probably the biggest reduction in workload is on the domestic hot water front. This has shaved off the amount of work to a fraction for this front. So what we have here is we can select the number of stories, we can select the number of tapping points, and then we have 4 options on the right hand side for how our domestic hot water is distributed through our building. So we can select one of the relevant sections from relevant types from that, and we can put in some further information. There is some information that has to go in here if you have a type 3 or type 4 system. I've a very brief example here just to show the distance between the farthest tapping points, and then you measure the width and depth of the building from your external dimensions, and you plug all those values back into your PHPP here, and that will work it out itself. For domestic hot water storage, we can take either the calculated heat loss rate, or we can use the ERP value from the label. So we can select if the label is A, B, C, D, whatever, just plug that value in. If we have the more detailed stuff in the heat loss rate, we can do that as well. There are some more cruder values there that we can use. There's an automatic one which gives you a crazy high amount of heat loss from the cylinder. I wouldn't advise using that unless no alternative. Alternatively, we can put the insulation thickness in if we know that as a starting point. Let's say 50 millimeters of insulation in, and that will give us at least a calculation to keep us moving. Finally, then we put in our emitter type. So it's very simple. You just select the closest type here. So whether it's supply air heating, radiators, or underfloor heating. In this case, it was underfloor heating, so that's what's selected. And there are sections there if you pipes outside the thermal envelope. We should be tending to avoid those, but sometimes can't be avoided. So you can enter those there. And last but not least, we have our PV section, which pulls from our PV tab, and that will pull any information from that where relevant. And if we have solar thermal, there is a section here to fill out the solar thermal as well, and that will fill out all that section for us. And that will then bring us back to our verification tab. And if we have our 5 yeses in all of these tabs at the end of our design process, and we're showing that our overheating, we're happy with that, then the building would be ready to go forward for certification. So I know that may have dragged on a little bit longer than we had planned, but that's the end of my presentation. So I'll hand it back now to Helena. Thank you.
Thanks very much, Shane and Elena. That was great. Now we have a number of questions in already to the Q&A. So I wonder if you have anyone would like to add some questions, if you could do so now. And we might just run through those. Is that okay? So don't know. I suppose there's a straightforward enough one in relation to the certification to premium certification. I think you clarified that, Shane and Elena, through the conversation. So we're okay with plus, classic and low energy building, but presently premium cannot be certified to that level.
Yes, I suppose there, Helena, just to add, I suppose Elena and myself were discussing this, and I suppose there's good reason for that. I suppose the inputs that are needed for premium, given the very high standard of a premium dwelling, EasyPH is probably going to be underestimating some of the stuff that's needed for that, particularly when it comes to PV and the PER and stuff like that. So it's restricted at the moment to classic and plus, to where if you're deciding to go premium, it's full certification really, and that's the reasoning for that.
Very good. We have a query in relation to the trialing of EasyPH. I suppose it's a PHPP license required. Would that be correct, Elena? Or
Yeah, I mean, if you have a license for PHPP 10, you should have received in April the update. So PHPP 10.6, and EasyPH is in that download folder.
very good. A few, I suppose, more into the detail of the software itself. So is it possible to move an EasyPH to a standard PHPP by the route of exporting a .ppp of the EasyPH and creating a new full PHPP?
So I'm 99% sure, yes. So from EasyPH to PHPP 10.6, if you use the import-export tool, you should be able to do that. I recommend that you do that using the option of export only values and not formulas, because you don't have the EasyPH worksheet in the normal PHPP. And the other way around, I don't think it would work. It might work if you only do geometry. So if you only export the same as with EasyPH, if you only export the geometry worksheets, but I haven't tried it, or we haven't tried it. So the other way around, definitely yes. But into EasyPH, I'm not sure.
Okay. We have another query. Is the input of external factors in Windows solar shading by EasyPH any different from standard PHPP? No. And again, the recommendation to use design PH where you can, I suppose, have some of that.
Yeah, absolutely. I think that's a good point. Where design PH is used, you're going to get more accurate results, and I suppose when we're looking at things like overheating and all that stuff, it's design PH is definitely superior, no question.
Very good. Can you input a compact heat pump units too from a drop-down list? Very good.
Absolutely, and I actually probably glossed over it in my presentation. But if you look in the EasyPH tab, there actually is a section for compact heat pumps, and you can assign them in the heat generator type as compact heat pump, and then select one of the compact heat pumps from the drop down list. So it's actually very easy if you have those type of systems in it. It's just really straightforward. There's no great complications there.
Very good. And I suppose, can you use different heat emitters? So if you had a combination of underfloor heating and radiators or items such as that, can that be managed through EasyPH?
I can't see any problem with that. Elena, would you have any thoughts on it? If you had to say like underfloor heating downstairs and radiators upstairs?
I think that the issue is with the assumptions for the distribution losses from the heating system. I would just say select the more conservative,
higher temperature
the one
one.
that would lead to more
that
losses.
that would be typically what you would do there. If you have, say, radiators at 55 degrees and underfloor at 35, you would select radiators, which would assume everything is 55. So yeah, it doesn't seem any problem.
Okay. We have another quick query in relation to, is there a danger by hiding multiple tabs and removing the need for input of electrical appliances, etc., that the PHPP is becoming a data entry tool rather than a design tool? There you go.
Yeah. Excellent question. We had a lot of back and forth internally about what we can take out and we can leave in. I think that's also part of the reason why you cannot do premium, because the devil is in the details. And once you want to do really high reductions in your energy demand, then you have to look at all those details. But for a normal or typical passive house classic, we are sure that with EasyPH you have enough information to have a robust design. We are not taking out any of the detail that you need for the whole geometry, and the quality of the thermal envelope would certainly be passive house, and you still have to consider all the systems, right? It's just the level of detail at which you can go into considering those systems. So we are sure that you can still use it as a very good design tool.
Yeah, I think I'd echo that. I think if you're using EasyPH, generally the aim will be here to try and keep the costs under control for the client and reduce certification costs and modeling costs, etc. While still giving a decent result. I think if you need high levels of design input into it, you probably should still be going down the road of traditional modeling. Even if at the end of that you decide to flick it into EasyPH for certification or something like that. So yeah, I think the reality here is a lot of people will probably still use the full PHPP for certainly the earlier element of the design, and then maybe certify using the EasyPH approach, something like that. So depending on the complexity of the project and various other factors too. So
I kind of have a query, I suppose, myself. You refer to the slight penalty of the 0.3 watts per meter square. What
correct.
heat load? Sorry, was it?
Yeah, that's I suppose one of the things that I've modeled a few projects in house here to see how was the performance of them comparing to full PHPP compared to EasyPH. And I suppose EasyPH errs on the side of caution a little bit, so you will tend to get slightly higher results from my experience on the demand and load. So in the case of Barry's house here, it was in the order of about 0.3 watts per meter squared. So that's, I suppose, 3%, you could say, of a difference. So you're getting a slight penalty there for using EasyPH, but I suppose the big saving could be several thousand in fees for certification and design. So most people might consider that a fair enough deal. I think if EasyPH was erring the other direction, I think it would leave, I suppose, questions really been answered. Why would you bother going the full road if you're going to get worse results? So definitely, if you go the full road, you'll get more accurate modeling and therefore a possibility of a lower load or space heat demand. That's just been my experience so far with it anyway.
One other question. One other question. It's actually Tom. Similar. I assume it was similar, Tom. I was supposed to ask myself. I assume using EasyPH can reduce the cost of certification. Do you have a sense from the feedback so far, Lynn and Shane, what that kind of what the scope difference might be for a certifier at the using this tool, or any sense?
Elena, do you want to start with that one?
I mean, we are certainly can reduce the work for the certifier. I guess one of the main points where we have to be a bit, or we need less of a detailed review, has to do with the mechanical systems, right? Because there's some, like, the inputs are very easy. So you have a normal data sheet of your heat pump, and then you just compare the COP to the one in the PHPP, and that's it. Whereas in the full, using the full PHPP, then we also have to look at all the distribution pipes and so on, right? So I think those detailed calculations are no longer needed. So then the review of the certifier also do not include that. And then it depends on the project. If you choose catalogs from thermal bridges, then that's also something that saves time because they're similar to the ones in your project. There's no need to check any specific calculations. But I guess those are the ones in which we will expect a reduction in the time for the designer and for the certifier.
Yeah, I think our sense so far, Helena, has been that certainly the workload for the certifier will be considerably less, and I think it will enable much more competitive certification fees to be offered to clients going down the road of EasyPH. I suppose where we have to be a little bit careful, is that if a scope of certifier is based on EasyPH within certain parameters. The cost of changing from EasyPH to full certification could rise, considerably. So I suppose clients need to be on board from day one with going EasyPH, and I suppose, as Elena said, on stuff like thermal bridging and all that kind of stuff, I would echo that. I think there's a need to try and design out the thermal bridges as much as possible from day one, rather than trying to compensate for them later on, which is where the time starts dwindling away and the cost starts to rise quite considerably. So I think, yeah, if someone's going the road of EasyPH, I think they can generally anticipate considerably lower certification costs. So certainly we're gearing up our team now to deal with EasyPH, and we have one of our staff in the office is actually going to become a full-time EasyPH certifier. So they'll be working on that day in, day out. So it should be able to get that cost down quite dramatically.
That's all positive. Very good. Because it is always a challenge, that final sum of money for the actual certification.
It is, and it can be considerable. It can be considerable.
Very good. And we'll do one final question and we'll try and get finished in the next minute or two. We have, can the EasyPH be used as a simpler design tool for NFIT projects where it's not necessarily for certification, but to aid design? Do you have any thoughts on that?
Yes and no. So, I mean, technically, you could still use it for certification if your retrofit is passive house. You just cannot verify compliance with the criteria for NFIT yet.
Okay.
So that's the only thing that would be a bit of a difference. There's a couple of things that we need to review for that to be possible. That's why it's not an option right now. So you could start using it, but then you cannot verify the criteria.
I think that's it in terms of questions. I don't know if anyone else would like to add anything else. I'd like to thank Brian Flatz and Yvonne, Brian for supporting on the IT side, and Yvonne for helping in terms of bookings, and she's a powerhouse behind the PHAI every day of the week. So just to acknowledge both of their support in organising this event and all of our activities. And to Elaine and Shane for the great introduction to EasyPH. So excuses are up now. We have to tackle that tab and get familiar with this. So thanks very much. And to Caroline as well for joining us today. And everyone knows her now, so you know who to contact you if you want. And again, if you'd like to, we'd love to have you, any additional members who are interested in joining and kind of supporting and helping to learn, and from the great membership of very experienced passive house designers and industry. So again, if you'd like to join that gang, you can check out the website. Is that okay? Thanks very much, everyone.
Thank you very much.
Thanks, Elena.
Thanks, everyone. Thank you.
Thanks,
Bye-bye.
everyone.